Hello, in this video, I'm going to introduce another formula where the integration of a simple rational function. Alright, okay, let's look at what's the meaning here. So integration of this form where there's a fx and there is a function up and down, and there's a fx and up there is a differential of the denominator. So but before I go into this form, we have to go some basic. So for the first type, that if you integrate 1 over x dx, alright, there is a way of proving that integrate 1 over x you were getting something, but I'm not going to discuss in this video. So I will mainly tell you that integrate 1 over x, you are getting ln of modulus x plus c. So as you know that integrate ln, you are getting ln x plus c. So because you know that differentiate ln, you're getting 1 over x, right? And you differentiate ln negative x, okay, differentiate ln negative x, you are also getting 1 over x. So there are two possible functions. When you differentiate, you're getting 1 over x, which is ln x and ln negative x. That's why we put a modulus. Alright, so okay, second, then there's this formula. So if you have a over with ax plus b, a over ax plus b dx, or okay, very simple, let's say 1 over ax plus b. So if this is linear and this is linear, right, linear, and this is 1, so linear, it must be linear, so it will be ln modulus of ax plus b, ln modulus of ax plus b. So the coefficient of x is a, so we just divide by a, then we add a c. Alright, let's move on to these two examples first before we going for the these two formula before for the third formula. Alright, so let's see some examples. Alright, okay, let's look at these examples. So I think these examples is something like this. So you can just factorize the constant out, okay, constant. So 1 over 3, and you have 1 over x dx inside. Right, integrate 1 over x, integrate 1 over x, you will have ln modulus x plus c. Okay, as simple as that. So let's move on for another examples. Alright, okay, let's move on this week with these examples. So we have 1 minus 1 over x, right? 1 minus with 1 over x to the power of 2. Oh, sorry. So I think I just put a, so if 1 over 2, we said 1 minus 1 over x. So 1 minus 1 over x, if you integrate, you will integrate 1 dx, take away 1 over x dx, right? So integrate 1, you were having x. Integrate 1 over x and ln modulus x plus c, right? Very simple. Okay, we will go example by example from the easy to the hardest one, right? Okay. This will be a linear, right? It's a linear function. So with 1 here, so I'm going to use this formula, right? You have to practice a lot so that you know which formula for you to use. Okay, for example, this one, very simple. You just put ln modulus 2x minus 1, right? Ln as linear, you put ln 2x minus 1, and this is a number. So then you have 2 here, right? The coefficient for x is 2, so you just put 1 over 2 here. That's the way you integrate this function. Alright, okay, let's look at this. It's still linear, right? It's still linear. So it's a number, so we just ln modulus 5 minus 2x, right? So what is the coefficient here? Negative 2, right? Coefficient a, so divide by a. So divide by 1 over negative 2. Or I can say negative 1 over 2 plus c. So quite easily done. Alright, okay. Same thing also here. It's not 1, but it's linear here, right? It's a linear, it's a number. And this is linear. It's okay, so we can take out the 6, right? We can bring out the 6, then we have 1 on top here. So 1 minus 3x dx. And this is linear, and we can apply this formula. Okay, we can apply this formula. So 6 in the bracket. So you're going to integrate this. So ln modulus 1 minus 3x, alright? Ln modulus 1 minus 3x. But don't forget to divide by -3, the coefficient for x, 1 over -3. Then after integrate, you just put a plus c, alright? So then you have 326, which is -2 ln 1 minus 3x plus c. It's very important to understand this, alright? I will give you more examples so that you have variety, or you have can do it and practice, okay? Exercise. Alright, okay. These examples. So now you have very competent already, right? So you can try first. So this one is a single term only, right? Then you have 3 terms here. You can divide each term by x, right? You can divide each term by x. So plus with 5 over x dx, right? So then you integrate, then 2x squared over x, you will have 2x plus with 1 plus with 5 over x dx, right? Okay, now you're going to apply some basic rule, and this one is integrate. Okay, this one is using this formula. So you will integrate 2x as usual, basics. So 2x squared over 2, 1 plus 1 over 1 plus 1, 2. Integrate 1, you will have x. Integrate 5 over x, 5, 1 over x. So 1 over x is ln modulus x plus c. So your answer will be x power of 2 plus with x plus with 5 ln modulus x plus c. Alright, I'm going to straight to the point and teach you what you're supposed to do if you have this type of problem. Okay, hope you do more practice. As you do more practice, you will become more competent, and you will know what formula to use, and you will and easy to study the later part of this topic. Okay, the concept, the technique of integration. Alright, okay, let's continue with this example. Okay, this formula seems like you can't using this formula, right? You can't using this formula, and you also can't using this formula. What's the reason? Because you can't see there is a number on top here, right? So it's like 1 over ax plus b. This is not 1. This is an unknown. It's a linear and linear, right? So, but for this type of cases, you can doing long division, right? As you see that this is improper fraction. So before you decide that which formula to use, it's better for you to make it become a proper fraction, as this is 2x power 1 and this is x power 1, linear and linear. So we can try to divide, alright? It still can be simplified, because 2x minus 1 can be divided by x plus 1. So which you have 2, right? 2, then you have 2x plus with 2. 2x plus 1, 2 times 1, 2. So minus 2x minus 2x, you have 0, 0. So you have -1, -3, right? -1 minus 2, -3. So I do some division, okay, long division, so that I can then I know that this will be my px over dx, right? So I will getting the quotient plus with the remainder. The remainder is -3 over with the divisor. Now I can see there is a hope for applying this formula here. So let's rearrange this, and you have 2 positive negative, -3 over x plus 1 dx. So you are getting this, right? Now you can see, you can apply this formula, right? This formula. So, okay, I straight away integrate, easy. So integrate 2, basic rule, you're getting 2x, right? So -3 is okay. I just put -3. So -3, actually this is -3 times with 1 over x plus 1, right? -3 over x plus 1 is -3 times with 1 over x plus 1. So to integrate this, you have to put ln modulus x plus 1, right? Modulus x plus 1. And the coefficient for x is 1, divide by 1. So you're getting 3 also. So plus with c. Alright? As simple as that. So it means that for this type of question, you have to perform some long division. Alright, okay, let's move on to these last examples. So there are many more types of integration involving these two. Alright, so I have discussed quite a number of them. So hope that you actually can understand. So as you see, this is also an improper fraction. This is linear. If you see this is linear and this is a quadratic, right? So we can perform long division. Okay, we can perform long division to help me in integrate this function here. So I have 2x minus 1. So this one you can't perform partial fraction. Alright, you can't write this into partial fraction because there is only one linear term here, right? So for this type of cases, so you have to do long division. So you have x, right? X and 2x, you will have 2x to the power of 2, right? X and 2x, you will have 2x to the power of 2. So you can eliminate this. X and negative 1, you will have negative x, right? X and negative 1, you will have negative x. So then you have to minus, right? You have to minus out. So you see x, 2x, negative 2x squared, right? So x and negative 1, negative x. So you minus out this, you have 0, and this one also negative x, negative, positive, you have 0, right? So you give you 3 here. So means that later you can write in the form of proper fraction where the quotient plus with the remainder of 3, right? Remainder is 3, divide by the divisor 2x minus 1 dx. Now it's become simplified for you to using this formula. Alright, okay, let's continue. Integrate x, you will have x power of 2 over 2, right? And 3. So 3 over 2x minus 1 is just like 1 over 2x minus 1, right? 1 over 2x minus 1. So what I should do here will be, okay, I'm going to write it down so that you have better understanding. Okay, integrate x dx plus with 3 integrate 1 over 2x minus 1 dx, so that you have better understanding here. So integrate x, you will have x power of 2 over 2, right? So for this one, 3. So I integrate this one, integrate 1 over 2x minus 1. So which belong to this formula, right? 1 over 2x minus 1. So I have to be integrate this, I getting ln modulus 2x minus 1. And the coefficient for x is 2. So I just putting 1 over 2 here. And everything have done, integrate, right? Seems like complicated, but after you simplify by using long division and apply this formula, it becomes simple. So which is x power of 2 over 2 plus with 3 over 2 ln modulus of 2x minus 1 plus with c. Alright, I think that's all for this video. I've talked about first part of part 1, part 2, how to apply these two formula, and later I'm going to introduce this formula and how to apply this formula. Of course, you need all this knowledge in order for the third formula. Alright, okay, see you in the next video.